This can be used on existing buildings. It can be used on new buildings, anything you want. So, I'd love to have input, and I will say, if you have a question, just raise your hand. I like to do that as far as interactive sessions. And I'm going to be moving around a little bit so that, we can have a more intimate time together. That's just another slide for what we have. So goldfish. Goldfish are notoriously have a very small attention span. So it's rated that they have 9 seconds of attention span. So I'm glad there's no goldfish in the audience. But Microsoft Corporation has put together a study that said that people, humans, have even less attention span than a goldfish. So make sure you get next to somebody and have them wake you up if you fall asleep. So one of the things about this conference is they talk about learning objectives. So when we leave this session, I want to make sure that you have these things covered. You want to leave with this information. So we're going to talk to you a little bit and enlighten you about the condition of the current environment as to the future possibilities within buildings itself and within BAS systems. I want to talk a little bit about illustrating the high performance of building systems and the BAS. I want to focus on data collection. We're going to talk a lot about data. Hopefully it's not too much about data, but how you use that data to maximize performance. One of the things is key performance indicators. I'm going to talk a lot about key performance indicators. I'm going to talk about why you do them, why they're important, and then give you specific examples of how you can take key performance indicators in your work today and have them measure your performance. And then also, you hear a lot about BAS systems, but you don't hear about the networks behind them. And the networks are very important. We want to make sure within cybersecurity that we network these things together, and especially with IoT, there's so many systems out there that have building processors in them that they are connected in the appropriate way. The agenda kind of follows the learning objectives, so I won't go too far into it. I do have, there's some keys in histories. Histories are important within the BAS, trends, and graphics. So we're going to kind of focus on that a little bit. We talked about cybersecurity, and then we'll have some case studies or examples. So a little bit about me. I think I was introduced before, but there's some specifics that I have. Been in the industry for a long time. My title is Director of Energy Engineers, so you kind of know where my background comes from. But I run a group within our company called the Solution Sector that does smart and intelligent buildings. I've been with the AEE, Association of Energy Engineers, for a long time. I'm currently on the board of CABA, which is now ASHBE, which is basically a smart building association within North America. And I'm involved with ASHRAE a lot. I've been involved in the society level. I'm currently on the ASHRAE 90.4 standard, which is high performance data centers. I'm on NIST Global Cities Team Challenge that we kind of are promoting smart buildings and smart cities. And I'll have some examples of some of the work we're doing there. This is a little bit about our group within EXP. EXP is a top 10 design firm, but this is my group that does smart buildings, commissioning, and energy management. We're the only consultant that does master systems integration, if you know anything about that. So we have a lot of expertise in the smart building arena. So this is the base case of what we're talking about today. The last item down below, 40% of all greenhouse gas emissions in the world come from buildings. And I think you've read about that a little bit. So that's what we're trying to address. But the problem that you have is in large buildings, only 60% have control systems in them. That's basically even a minimum BAS system. And then small buildings, which 50,000 square feet is not really so small. There's a lot of those. Only 13% have BAS systems. So I think that's one of the things we have to address, more of these buildings, and if you are involved in any of these buildings, let's kind of attack that area. We're going to talk a lot about intelligent and smart buildings. So I wanted to give you a definition, and I always hate bringing up a definition. I like to use somebody else's definition, and this is kind of a good industry definition. So I'll read it. An intelligent building gives building owners the flexibility to integrate individual building systems to deliver an enhanced working or living environment for occupants and optimal equipment functionality and better management of resources for the owners. Lots in there, but I wanted to kind of focus on a couple things. First, it talks about the occupant. So it's focused on the occupant, and it's talking about integration for optimal performance and to benefit the owner. So if you try to take that, that's kind of what we're all going to talk about today. The benefits coming out of this are better performance, interoperability, occupant satisfaction, and return on investment. So all those are key performance indicators on a very broad sense. I think you're all aware, hopefully you're all aware about BAS systems and kind of how they work. One of the things is, there's a lot of contractors out there installing BAS systems, and whether they were specified or they're just kind of plugged in, these are some of the things that you run into if you don't tell the contractor or focus the contractor to solve these issues. These are the things that cause your system to bog down. So one of them is data overload, and we'll kind of get into it a little bit more, but more and more things are being connected. Communication cards are out there that have 300 or 500 points, and you can easily get overloaded. Operational knowledge and understanding. I don't know how many operators here are in the building. I'm sure facility management, there's a lot of people. Don't take it the wrong way, but there's definitely a knowledge base that needs to be improved here. So we'll talk a little bit about how to do that. How do you measure high performance in a building? There's many different ways, and we'll talk about key performance indicators. We're going to talk about basic systems and items that should be in a BAS to try to address that. We'll also talk about some extra stuff that you usually don't get, and we want to make that to enhance the building performance. Another problem is slow data transfer. Again, we're getting back to the goldfish. We don't want to lose people's attention. Unsecured networks is key within a BAS system. We want to make sure that cybersecurity is being addressed, and we'll talk about data and where it's stored and things like that. Systems not communicating, dead points, lack of commissioning. Those are things that we see in the industry all the time. Those need to be addressed. Points not linked or addressed. A point that's not connected is still utilizing all your resources, and it taxes the system. So let's address that. And then visualization. We want your BAS to tell you what to do. So the first point was data overload. You can see there's a lot of that. There's a lot of systems out there that are dumping a whole bunch of data, and a lot of people pull all the data in, and they want more and more data. And I'm saying kind of, whoa, let's slow down a little bit. Ways to address data overload. Look at, don't pull all the points. Look at the points you need and just pull that information. The other thing is, when you talk about data, don't store it all on the edge being the end device. So you don't want to store that. You can store it maybe for a couple hours or whatever you need, but most of it should go back to a thing called a data lake or a data storage space. This could be on-site or in the cloud. Don't create trends on all your points. There are some manufacturers that do that automatically, and it's fine to do, but if you're not going to use that, there's no sense in trending that information. I don't know if you have any understanding about data analytics software, but that's key to making a high-performance building. There's people on the floor this week that sell these, and it's something that if you have all these issues that we're talking about, it really can enhance your performance if you do it right. And you don't have to do all that they do. You can just do parts of it. Focus on what your key performance indicators are. Fault diagnostics, really cool ideas. So the fault diagnostic alarms have been out there forever. And alarms typically is when something happens that's bad, an alarm will go off. Well, faults go off before an alarm. So they're not necessarily the system isn't broken or it hasn't failed, but it might be leading to failure, or it might need something to be addressed to make it work better. And that's what basically a fault is. Graphics and tools. Excuse me?
Give us an example of a fault.
I'll do it later, but basically a fault might be, one of the things that we do is before we start a project in commissioning, we'll do a electrical overload of a motor, and we'll do a trend of it and see what its signature is. And then if that signature changes, that means that you have an issue that's coming up. So the motor won't fail, but maybe it was hit by harmonics, or there was a single phasing, or maybe it's ready to fail. And this way, it'll tell you before it fails. Great question. Thanks for asking. Graphics and tools. We want to be able to use the graphics and the tools within the BAS. And a lot of times you get the bare bones. You don't get everything. So inquire about getting more stuff, because there's more ways to show the same data depending on what you're looking for. We want to turn data into action. So if you can take away one thing, that's a good phrase, turning data into action. We want your data to tell you what to do. And we use an analogy of a car speedometer. So your BAS system should be like the dashboard on your car. It should be able to tell you when you're driving, you look at data every day. You might not think of it as data, but it's data. How fast are you going? What's your fuel economy? Is my turn signal working? Are my lights turning on? You need to know all those things. Well, that's what a BAS system does. User knowledge. This is an important part, and it's almost, so usually when you design a system or you start installing a system, you don't know who's going to operate it. And what we try to work with our clients and with the contractors is look at who's going to operate this building when you turn it over, because that person is going to either make or break the performance of that building. So there is training required for any operator, usually within the specification. Don't just tell them how to, how your system works, but tell them how to use your system to make the building perform better. So, does the person have good computer skills? every quarter for, and train better, so that they're available and they're watching. They're not on their phone the whole time while you're training them. There's a thing called Building Operator Certification. It's called BOC. This is something that the federal government has incentivized utilities, and they pay for this training, so your building operators it doesn't cost you anything, plus they pay for your time. So they pay the owner for you to attend this. So it doesn't cost them anything, they get something out of it, and the whole idea is that buildings perform better and they reduce their energy consumption. Ask the owner for additional training, and you can that goes back to that one. And then try to focus on tools within the BAS, not necessarily just the BAS. A lot of times what we do is we do commissioning, and we get the building operators to get involved in the commissioning, because the commissioning, we come out with these things that are like, wow, my system never did that. Well, it's not really supposed to do that, but we make it do that to make sure that it's working the way it should, so that when that does happen, the operator knows, oh, that's what he was talking about, and that's why it happened. So then you can figure out how to fix it or what was the problem. This comes out of the NIST work, and it's a really detailed graphic, but it talks about the different levels. You can see 1, 2, 3, 4, 5, 6, 7. And so the edge devices are on level 1, the building, services, infrastructure, then the connectivity, then you got power, information management, that's now you're getting into data, you're getting into autonomy and automation, and then the service enablement of those systems. And then the vertical things talk about KPIs and where those would fit in. So those different colored at the top would be who would benefit from those things, what departments. We talked about systems and networks. So these are all different things that you have in your building, and typically you'd see HVAC is in the BAS, but a smart building tries to integrate more than just the HVAC. And you probably have done lighting control, and there's that on the floor, but usually the lighting control might be a separate system. Well, connect those two together. Energy metering, again, it might be an electrical meter that's sitting there by itself. Well, it'd be nice if the electrical meter was telling the BAS to turn down the chiller or something. And then when we talk about occupants, connecting to the fire and life safety or monitoring of utilization, doing elevators or access control. Well, we did a building recently where you come in with your cell phone or your key fob, and it knows, like my office, it knows when I come into the building, it knows who I am, where I live, so it turns on the lights. First of all, it tells the elevator to come down, get me, tells me that I'm going to the 3rd floor, and it automatically takes me to the 3rd floor. I get off, the lights in the corridor are on. It knows that I'm coming to my door. I still have to key fob in so that it registers me, but the lights up to my office are on, and the HVAC system is set to the temperature I like. And all those done automatically. And if you do that, people are excited. They're like, hey, I like coming to work when people, I can control things with my cell phone. Those are things that people really like, so that's good. And then we have charging. So, we haven't really gotten into that too much, but, what if your cars could power your building during the day? Like, let's say they're all charged up and maybe you lose power. Well, it's still an alternative power source. So it doesn't necessarily have to charge and pull power. It could give you power, depending on if you put the rate schedules in, and maybe it's better to use that power than to use the utility power. Networks. A lot of times networks are an afterthought. What we always try to do is have a common, we call it a BLN. The common network connects all these different systems, but there's a thing up there, IT, so there's OT. So there's IT, which is like your typical IT department, handles all your computers and everything that's connected to your corporate network. But OT is more connected to, your meters, your BAS, things like that. You kind of have to know how that system's going to be installed, who's going to install it, who's going to manage it, and who's going to operate it. But you want to make sure that all these devices are protected and that there's a solution behind them. We talk a lot about network switch. So all the network that's put in has switches. So a lot of systems you go out there, you can just plug into it and I can have access to your network. Well, a network switch, you won't be able to get on that network without, pre-confirmation. So a device that's not recognized, that's not already programmed in, won't happen. Yep.
What is OT?
OT is operational technology. And then, make sure that systems and solutions are final commissioned. And, you can always use the system to do ongoing commissioning process. This is a diagram showing different systems within a building, and you can see the different colors are kind of different types of networks. You can have like a typical, maybe an N2 network, then you can have a backnet network. You can have a Modbus network that might go to the PV panels or to the electrical system. But all of those things need to be interconnected. And you can see, if you design the building and design the network correctly, you can tie all these things together very seamlessly, and you don't have 5 different networks in your building. Because that's typically what will happen is if you get the contractor to just put in a lighting control system or a BAS system and a energy metering system. You want all those things to work together, and you'll save a lot of money if you do it that way.
Question?
Yep.
You're talking about energy. You go around the country, right?
Well, I do consulting all over the world, yeah.
Now, in the last 15 or 20 years, electric rate structures have changed a lot. You used to have time of day, off-peak, demand. A lot of that's gone away. For instance, it's gone away here in Baltimore. What do you see around the country? Do we still have time-of-day rates in many places? Do we still have demand that would foster things like ice storage and so forth? Like, what do you see as you go around?
Yeah, I mean, right now, what's happening, that's a good question. It used to be time of day rates where this time of day, it was this rate. Now, it's projected rates. So you might have a standard rate at night, but during the day, you're on the commercial network, so you don't know what it is. So you basically, if you're in that type of scenario, you're going to pay whatever the utility is going to sell it to you for. So that's where tying all this stuff together is really key. It's even more important because those rates, you could pay 10 times. If you look at Texas, that happened when they lost power. You read articles about people's bills went up really high. Well, because there wasn't that much power, and the power that they were getting was real expensive, and so they had to project it down to the customer. Because remember, a utility company doesn't really sell your power. They're basically just transferring it. So they might buy it, and they're going to transfer that cost to you. So whatever they spend to produce power, you're paying for. They don't get hit with anything. They never lose money. Talking about different network levels, so we remember that diagram before with so many levels. This kind of goes into the first 3 levels. So the field level devices, those are like sensors, VAV boxes, actuators, things like that. They're the end devices. And then you have the automation level, which has more controllers. And you can see there's some lawn controllers, there's third-party integration systems, there's BACnet systems, there's Modbus systems. All those are on the control level. The key here is you want to make sure that whatever your end device is will still operate if you lose the network. So that's key, because the automation level controls all those end devices, but you want to make sure that there's some processes in the end devices to keep things running. And then you have your management level where all the control goes up to, and you can have remote interfaces in that level, and that's where you can see the IP or Ethernet. That's usually where the IP and Ethernet is. Now, you'll see on the floor show that there's sensors and actuators that have IP now. The IP is going all the way down. And that's, some cybersecurity people say, well, that's not a good thing. I don't want that. And what you can do is, when we talked about the BLN, you can have a building level network off a second NIC. And so you can actually separate and set up a virtual network that helps you with cybersecurity. But the management level is where maybe the data is, but that might be in the facilities office. But you might want to go up to like the C-suite with some of this data. And we'll get more into the KPIs to get into that. So data, how much data? Where should it be stored? You have to answer these questions. Who's going to use the data? Where is that data going to be located? And that has to do with who's going to use it. And then what data do you need? So that gets back to your KPIs. And what I would do is take this back to your executives and say, what within my BAS system do you want to be reported on? And what can help your bottom line? So think about that a little bit. There's, within the NIST association, they asked us, well, what KPIs should be standard or typical? And I'm like, you can't, there's like energy stuff is all well and good, but every business has different ways that they make money, and ultimately that's where your KPI is. We don't want to get data overload, so we talked about that a little bit. And you want to set up a business case for the BAS system. And we do this with a lot of our systems. I think you'll know in the BAS system, there's a thing called open systems. So open systems are defined differently for many different people. And even within each one of these categories, there's levels of openness. So there's an open protocol. So this is a communication language. This is like BACnet or Modbus or things like that. Those protocols are standardized, so manufacturers have to meet those. But manufacturers can also lock those down. So you want to make sure that you get the source code and you don't have to rely on them. Open products. So most products, if they say they're open, they work with other products. And typically within BAS systems, you don't see like a Siemens system talking directly to a JCI system. You can't put those together typically. But if you ever have like a home automation system, you've got an Alexa. Well, Alexa works with this one, that one, this one, and you can kind of, it's a family. So that's kind of where we're trying to go. But then delivery. So, there's no Amazon for building automation systems. Where do you have to buy these? So typically you have to go to your local vendor or your distributor, and that vendor or distributor has this territory, and they handle that territory. And you can't come in and sell that product unless you work for that person. Well, that's called a closed delivery system. There are systems out there, products out there, that are open delivery. So they have multiple different vendors. So you can pick and choose, or you can kind of compare and get different bids from them. So that's kind of more of an open system that we talk about. And then also when you install a system, at the end, you go through warranty, you start into service. Well, who's that service contractor? Who's going to service that afterwards? Well, if you have an open system, you can now, if let's say you worked with Bob and you loved Bob and he was the one that installed it and you wanted to service it, but Bob left and now you got Dave. Well, now, I don't really like Dave. I'm stuck with Dave. Well, if you have an open service and support infrastructure, you can go back to Bob and he'll do the same one. So some of the benefits and examples. I didn't really talk too much about master systems integration. So not many projects are done this way. Usually an architectural engineer will design the building and it'll go to a BAS vendor and that person will install it. There's a thing when you're talking about Division 25, you're getting into a master systems integrator. So they bring all these technologies together, and that's kind of what we do. It's non-biased, so we don't have any, we're not trying to sell a certain product. Usually through the open bid process, the savings you'll get through bidding a BAS system will pay for our services. We work with educating the owners, the designers, the contractors, and vendors, because there's an old school network, old boy network that's out there that this is how I always do it, this is my process. Well, the smart building process is way different and they need to be understanding of that. And that has to do with budgeting, because typically, you know, your BAS system is under a mechanical contractor, so your costs are under there. Well, if that mechanical contractor doesn't understand smart buildings, then that money goes to him and your smart building now became less smart. We work with networking and communications to help cybersecurity. We help with responsibilities and the handshake. So when you have a lighting control vendor and an electrician, they need to transfer that data and it has to communicate properly. And how that's done is sometimes not, if there's miscommunication, it doesn't happen. And that's where we see things fall apart. So we help with that and define where those responsibilities are. So at the end of the project, you're not left with a bag of stuff. Those contractors are fully responsible to give you a fully working system. We help define the KPIs, assist with coordination and clarifications, and then commissioning and troubleshooting. This is something from the NIST. This has to do with KPIs. This is like a good starting point. It gives you all the different KPIs that you could have. So there's, different colors. You got educational things, maybe if you're in a school environment or something like that. You've got collaboration. So if you have multiple departments within your organization that need to communicate, that would be good. You've heard about wellness, that's all indoor quality, things like that, cleanliness, safety and security. This has to do with fire and life safety, but it can have other things too. And then technology and operational and utilities. These are some defined KPIs. So these are things that we do within our buildings. And I'll kind of go into them, like energy and water. You can tie your meters into the system and track use. And so you can add a fault to say, I lost that meter. So a lot of times we'll go to buildings and this meter had stopped communicated. And nobody knew about it. It was like set up a fault. And that should be something, you want to make sure you get clear data. And because once you lose data, you lose that continuity of data. And you need that to do any analytics. You can do faults for too high or too low. So let's say you don't want to go over a peak demand, or you don't want your bill to be a surprise. You can set limits on that and have a fault. You don't necessarily want an alarm. You're not going to shut down any systems, but you want to know about it right away. You don't want to wait until the bill comes. And then setting daily, weekly, monthly limits. So this is more overall use, hourly use. And then looking at equipment efficiency. Chiller kW per ton based on temperatures, boiler percentages of operation efficiency, and faults if anything's out of range. And that was where we were talking about the motor. If something gets out of range, what we initially set up in commissioning, if it gets out of that range, then we get a fault. Operationally, if something is running after a schedule, let's say it's running 24 hours, you can have a fault. I'm sure the building operator might know, or they might not know. It might have been somebody came by and accidentally hit the hand on a piece of equipment. Well, now it's running 24/7, and that's going to affect your utility bill. You want to know that before that bill comes to the C-suite. Set points that are out of range. Every corporation has set points that they, for let's say a room. I'm sure this place, wants it to be at 70, 72, whatever that is. Maybe somebody is hot and they set it for 65. And once they set it to 65, it stays 65, whether that person's there or not. You want to know those things. When we talk about occupant comfort, let's do faults that the temperatures are outside some set point. So it'll alarm me if it's not meeting something or somebody set something outside of your norm. Indoor air quality, you want to make sure that people are healthy. Well, why not set up faults if something happens? Humidity, and then even glare. If you're measuring lighting, you can define whether there's a glare instance, and maybe that's an issue that needs to be addressed. And then within maintenance, you have a work order system. So if your filters are not changed regularly, you would get a fault. Simultaneous heating and cooling is good, or if doors or windows are open. You don't want your HVAC system to be working full, trying to maintain a space when the doors or windows are open.
Do you try to monitor things like open windows?
Oh, yeah.
What sort of sensors would you use?
They have a magnet, it's a little end switch that it's just an electric device. It's very simple. But when that frame comes off, it'll know. It's kind of the same things they use when you come into a space. It tells you whether the door is held open.
And these are wireless sensors?
They can be. Typically we don't do wireless, but wireless work just as well. It's kind of a security automation. A lot of security systems will have those. This is a little graphic showing, it actually was kind of creative because it was a college campus that was growing. So it showed, if you just look at their utilities went up. It almost doubled the utility use, and the utility cost went up. But their square footage was being added. So if you look at the BTUs per square foot, their actual efficiency was going down. So this was something that kind of turned the tides for them. The executives were complaining, but then the facility people said, hey, wait, look at this. We're actually doing better than what we should have been doing. So we talked about those examples of the KPIs. These are taking those examples and applying them specifically to certain equipment. So energy, taking BTUs per square foot or water per square foot. And there's benchmarks. So any building out there, the Department of Energy has benchmarks that you should be within this range. Set those benchmarks within those BTU per square foot, and you have your KPI. Efficiency. Chiller manufacturers know what their kW per ton is and boiler efficiencies are. So you can have your operators, kind of have a contest. How low can you get your kW per ton? And have, hey, I get free lunch if I get it below 0.5 kW per ton. Variable frequency drives. You see a lot of frequency drives out there running at 100%. Well, that's a problem. That's an opportunity missed. You should be running around 60%, 70%. So track that stuff. Equipment following the schedule. We talked about set points out of range. Setting your comfort range within a certain value. Setting your foot candle levels within a certain value. One of the things we didn't talk about is like sick days. So the BAS doesn't track sick days, but go to your HR and track your 6 days and then tie it to something in your HVAC system. Maybe filter changes or maybe humidity or indoor air quality. And you'll see that you are causing sick days or you're preventing sick days. And so you'll reduce the number of sick days, and that's money to the bottom line. Increase billable hours. Nobody really looks at that, but that's money coming in the door if you're a lawyer or somebody. We have smart buildings where people love to come in, and it's hard to believe. People come in the first thing in the morning and they stay late because they love the technology. They love to take their cell phone and be able to play with the lights and change the temperature of their space. Or, I know where Samantha is, and I can have a meeting with her at any time. They love that type of stuff. Tracking your work orders and seeing how long they stay open. That's a KPI that's really good. Now, it can work both ways, but if you work that and develop it, you can take that to, your executives and say, look, I took my work order delay from 5 days down to 2 days. And that's saving money for them on a lot of different ways. In revenue, you look at increased number of visitors. So a lot of corporations, that's not such a big deal, but retail, that's huge. You'll see a lot of places that'll run their air conditioning maybe a little bit colder in the summer, and they might open their doors. Well, that's not good. Energy, it brings people in out to the street. They want to get cooled off. So they come in, they kind of walk around and get cooled off, and they might buy something. So tracking the number of visitors, and that can be through a simple sensor that's counting the people coming into the space. And then increasing remote meetings. Now, that sounds like it's not a good thing, but if you look at the greenhouse gases with travel, if you have to have a meeting, a corporate meeting of 10 different people from across the country, if you can do it remote and use technology to enhance that meeting, then you can actually save the company money and their emissions go down. I'm going to go through a couple dashboards and maybe go quickly, so let me know if you want me to stop a little bit. But you can see how we transfer data into graphics and visualization, showing trends and how things are improving. Those are good things. And all these are kind of customized for clients. And here's one I really like. We talked on the left about a speedometer. That's showing you, you kind of want to be over to the left. Showing percentages, how your percentages have gone down. Equate that percentage to dollars is key. Looking at pie charts, trend charts with utilization, FDDs, how many FDDs are coming off in a daily basis. And if you can reduce your faults over a time period, that's good. And then in the bottom right, you can see those are definite faults. And then the green part is how much money that fault is costing you. So if you have simultaneous heating and cooling, that might be, let's say $1,000 an hour, where a filter needs to be replaced that's a fault, it might be 10. Well, who do you want to tell, or who do you want to go out and get that thing fixed? Which one do you do? Well, if you look at money, you do the one that's on the top. So you address those first and don't worry about it. I talked to another person today where they had 1,000 faults coming in, and that was a lot for a facility for one day. But if you looked at it, there was one piece of equipment that was like 750 faults was coming from that piece of equipment. So just fix that piece of equipment and you've solved, some of your fault issues. This is something we did for the mall, a big mall operator, and it was a neat way to visualize how well a building's performing. We did it on 4 categories: energy, operation, health, comfort, and maintenance. And we had criteria for each one, and each quartile would be either green, yellow, or red. So you could quickly see what your score was, so you can identify buildings that need the most support and bring those up. So the future, what are we doing in the future? Everything that has a microprocessor can be connected to your building network. We have a couple projects where we use video surveillance, the door cameras that would identify people, identify loiterers that are hanging out by the door so they can come in behind somebody else, so help your door access. Hoteling is a great thing for corporations. A lot of people are working remote. Well, why build a building for 100% of your staff if only 50% are coming in? So why don't you can downsize your building, have it at 50%, and then have half of the people in the office, and you reserve your office space, and then the next day, the other half comes in. And it's all reserved, and so that that's your space, and it's kind of cool. People like it. You do it through your phone. Janitorial equipment, everything's can be automated if you want it to be automated. Appliances, this is more on your home, but printers can do this, or plotters, things like that. The reason this is happening is because of 5G. This is from your cellular system. It's creating all these opportunities and more opportunities to increase performance of the building. Wi-Fi is internal to the building. You kind of need to watch. There's now BAS systems that are being put in that help that communication. So it's taken the cellular network and taken it into the building, because if we want to know, like if I want to know where you are, I can set up a meeting. If I know where you are, I can do like a GPS mapping to you, or I can set up a meeting. Let's say we have a meeting at conference room 10. Well, maybe I don't know where that is. I can look at my phone, click, it'll tell you, okay, turn right here, go through this door, go over there, just like you would with a car. Want to make sure that we're focused on the occupants, and then digital twins. So you have all this data, and you know what the building's supposed to do. You develop a digital twin that there's different definitions of digital twin, but basically you can have a digital twin of your chiller plant or something like that. So how it should operate, and then you compare that to your actual, and you can see if there's a difference. And if there's a difference, then you generate a fault. And that fault tells you, hey, look at your digital twin. You see that maybe something's not set right, maybe a pump's running or a valve isn't open. You want to know that. It can also help you with sustainability, pulling all that ESG data together, electrification, because you would know how much power a facility needs, and if I electrify it, can my building handle it? And battery management is another thing that's real good. So now we come to questions and answers. So hopefully you have some questions for me, or I opened up some stimulating ideas. Anything out there?
Measure, in particular, I know it's great to have a massive global approach, but if you were to check a box as to what's the low-hanging fruit for the maximum return, where should we target first?
Yeah, that's a good question. It's kind of hard to answer. Well, wait, let me answer this one first. Oh, okay. The question was, is there any like low-hanging fruit to this technology, and how can that technology be applied in an economic way? And there's really no, I wouldn't call it low-hanging fruit, but I would definitely look at your KPI and see where you can make the most difference. So one of them is metering. You know, if you get your meters, if you're not within your benchmark, you can immediately bring that down. The fault diagnostics is really good. Looking at, you know, some of these things you already know you have in your building. So if you have simultaneous heating and cooling, that's a problem. If you see 2x4 stuck in your outside air dampers, or if you see your mixed air plenum doors open because they don't want to freeze the coil, those are indications that you're doing something that's probably not right, and you need to increase your performance.